What is going on, everybody? Back for another video. You might recognize this problem. We did work it in a previous video, but in the other video we worked this using cylindrical coordinates. In this video we're going to use spherical coordinates to solve it. And you can watch both videos and see which one you think's a better way to solve it. Alright, so we want to find the volume of the solid that lies within the sphere, above the XY plane, and outside this cone here. Alright, so for the sphere, it says x squared plus y squared plus z squared equals 25. So we know here that rho squared is equal to 25, which tells us rho is equal to 5. I'm going to draw a picture of it too, but let's do this first. And then I've got z is equal to 2 times r. All right, let's draw a picture of this. I'll do it the best I can. I'm not very good at drawing these things. So we got a sphere here, and it's just the top half of the sphere, because you can see it's that lies within the sphere but above the XY plane, so it's going to be the top half of it. And then we've got this cone here like this. We've got a cone that comes up. All right, now what we have here is we have to set this up, and you can see rho is 5. Rho, that is the distance. That's this from here out to any point on the sphere. Okay, that's going to be rho. And we can see that, let's just write it here, that rho is between 0 and 5. And then hopefully you can also see that for theta's coming around this way. Theta's going to go all the way around. So theta is going to be between 0 and 2 pi. So those are pretty easy to get there. Now, what we have to get here is phi, and that's this angle here. Okay. All right. So how can we do that? Well, we have the equation of the cone here, z equals 2r. Okay. We remember square root of x squared plus y squared is r. All right, so let's use the fact that we know the relationship between spherical and rectangular coordinates. We know z is equal to rho cosine phi, and r is equal to rho times sine phi. So if we take these two and we plug this in for z and plug this in for r, we're going to get rho cosine phi is equal to 2 rho sine phi, and you can see the rows cancel out. And then if I divide both sides by cosine and both sides by 2, I'm going to get tangent phi is equal to 1/2. Well, I'll tell you what, let's do this. Let's divide everything by cosine. So we're going to get 1 equals 2 sine phi over cosine phi. So divide everything by 2, 1/2 equals, and sine over cosine is tangent. All right. So that tells us that phi is equal to inverse tan of 1/2. So you can see that phi is going to go from, inverse tan to pi over 2. That's going to be inverse tan 1/2 to pi over 2. That's phi. All right. That's the angle here. All right. Now, let's set up our integral. So if you look at this, we're looking for the volume. That's 1 dV, right? And we're going to write this in spherical coordinates. So we're going to get the integral inverse tan 1/2 to pi over 2. And then we've got the integral from 0 to 2 pi. And then the integral 0 to 5. And that's going to be, now remember, when we go to spherical coordinates, that's rho squared sine phi. And then that's what? D rho, d theta, d phi. All right. All right, so now we are ready to integrate this thing. So we'll look at this. We can do each one of them individually and multiply. So this is going to equal inverse tan of 1/2 to pi over 2. And that is going to be, that's for phi, that's going to be sine phi d phi. And then 0 to 2 pi d theta. And then 0 to 5 rho squared d rho. All right, so obviously this one in the middle, we can see that's 2 pi, and this one's easier to do also, but we got to do this one. All right, so we're going to get negative cosine phi from inverse tan 1/2 to pi over 2. Now let me write this 1/2 a little bit better. All right, so it's going to be that times, and then, well, I tell you what the heck, let's just go ahead and write it all out so nobody gets confused. And then we've got 1/3 rho cubed from 0 to 5. All right. So this one, we are gonna, let's keep that negative. I'm going to keep this negative out here. So that's going to be cosine pi over 2 minus cosine of inverse tan 1/2. All right. And then that's going to be times 2 pi minus 0 times 1/3 times 5 cubed minus 0 cubed. All right, so this is going to be negative cosine inverse tan 1/2 times 2 pi times 125 over 3. All right, so the big question is evaluate this thing. So let's come over here to the side. Now, yeah, we could punch all that into our calculator, but let's have some fun. Let's write this as an exact value, okay? So we want to figure out what cosine of inverse tan 1/2 is. All right, so I'm going to say let alpha equal inverse tan. Now you should be able to do this. You've done this in trig. So let's draw us our triangle. There's alpha. Tangent is opposite over adjacent, and so Pythagorean theorem, this would be square root of 5. And so we can see that the cosine of alpha, which alpha is this, so the cosine of alpha is adjacent over hypotenuse, is 2 over square root of 5. So this tells us that this is equal to 2 over square root of 5. And so this is going to be, I about messed up, didn't I? You see that minus? I forgot to put that minus right there. My bad. And so this is going to be negative 2 over square root of 5 times 2 pi times 125 over 3. And so that's a negative and negative, make a positive. When you multiply all that out, you're going to get 500 pi over 3 square root of 5. And that is your answer. And if you punch that in your calculator, you'll get 234.160491. Okay? So either one, if you have to give an exact answer or if you have to plug it into your calculator, well, you got both of them there. All right, so I hope you enjoyed that. I hope that video made you feel smarter. I appreciate you watching. Check out my other videos. Give me a like, share, subscribe, comment. And I will see y'all in the next one. Later.